All right, so let's formalize a little bit more here. On lesson 8.4, this is page 8 in your packet, kind of summarizing what we did with our 4-step process. So state, plan, do, conclude. In your state step, make sure to state your null and alternative hypotheses using appropriate symbols. Define the parameter, say what P represents or mu represents, and what significance level alpha are we going to use. We typically can pick that. It's often 0.05, or we might be told something other than that in the problem. Plan. For right now, in proportions, we'll call the name of the test a one-sample z-test for P. When we talk about means in another lesson, we'll change the name of that slightly so we know which type of test we're running, and go through your conditions, make sure that they have been met. In the do step, what we need to see is, what is your test statistic? Give some work for that. Show the picture, draw and label things, and then use your table to get the p-value that corresponds to it. Once we have that, conclude. Make sure you always link your p-value to alpha, since p-value whatever is less than alpha, since p-value whatever is greater than alpha. Use that to start. What would you do about the null hypothesis? Do we reject or fail to reject? And then make your conclusion always about the alternative. We do have convincing evidence for blah, blah, blah. We do not have convincing evidence for blah, blah, blah. Okay? Now, we've seen several cases where we are finding our p-value that is less than something or greater than something. In the case where we have a two-sided test, we have not really done any of these formally together, we will next. If we have a test where we are assuming the null hypothesis is P equals something, and we're looking for evidence for the alternative that P is different than, not equal to, this type being a two-sided test because evidence suggesting greater than or less than a desired value, we have two different sides, could give us our convincing evidence. What we have to do is when we get the area in the tail, whether it's to the right, if it's a value that's greater than our assumed null hypothesis, or if it's a value to the left that's less, we have to double the area to get the p-value. So you'll see that next. So a formal 4-step plan in our example here. Who feels job stress? A news report claims that 75% of restaurant employees feel that work stress has a negative impact on their personal lives. Managers of a large restaurant chain wonder whether this claim is valid for their employees. A random sample of 100 employees finds that 68 answer yes when asked, does work stress have a negative impact on your personal life? Do these data provide convincing evidence at the, now notice here, alpha significance level of 0.10, that the proportion of all employees in this chain who would say yes differs from 0.75. We just want to know, is it different than 75%? Not strictly greater or less, just either way. So this is going to be one of our two-sided tests. First, we'll fill in our state step. So our parameter, P, is the true proportion of employees who feel stress affects their lives at this particular chain. Our statistic was the sample percent, 68 out of 100, or 0.68. Our hypothesis for the null hypothesis is that P equals 0.75. The alternative, P is not equal to 0.75. Different from, so differs is the not equal to. And we were instructed to use a significance level of 0.10. So in our plan step, we'll name the procedure. It's a one-sample z-test for P. We'll check our conditions, random, a random sample of 100, large counts to make sure that a normal distribution models a sampling distribution. So our assumed 0.75 times our sample size, 75 is our count there, 0.25, so 1 minus our assumed value, times our sample size, that's n times p hat, or n times 1 minus p, my mistake, and that's 25. And they are both at least 10, so we've met that condition. So a normal distribution will model this well. So now on to the do step. I first, get this on the screen for you, want the mean of the statistic. So the mean of the sampling distribution is the proportion we assume, 0.75. Our standard deviation of our sampling distribution through our formula yields 0.043. Now, if you, I should slide this down a little bit, draw and label your picture next, to kind of put that together, be sure to label the mean in the middle. Our sample value of 0.68 is on the left. We're going to get this tail end value in a moment for our p-value. But because we're looking for evidence that is different, either side would yield convincing evidence if the p-value is small enough. So we'll have to keep that in mind. Over here, I've got my general formula. You don't have to write that down. I'm just kind of walking you through your statistic minus your null hypothesis, divide by your standard deviation. Make sure you do show these numbers though. And then that yields a test stat of negative 1.63. When I go to the table to locate the area that falls in the tail to the left of that, I would have 0.0516. But now notice I'm doubling that because it's a two-sided test. So 2 times that would yield 0.1032. So the p-value for this test is about 10.32, meaning there's roughly a 10.32% probability of obtaining a sample to be at least as different from 0.75 as we have observed purely by chance. Is that different? Is that low enough to reject the null hypothesis? So in my conclusion, I'm going to remember to link the p-value to alpha. P-value of 0.1032 is greater than alpha, which we were told to use 0.10. We will fail to reject the null. Notice I described what's going to happen with the null. And now I'm going to make sure to be clear about the alternative. We do not have convincing evidence that the true proportion of employees who feel stress affects lives differs at this company from 0.75.